Well, to make it short, it means that I'm working on innovative, sort of exotic mission concepts to be addressed with our next generation of launch vehicles, Ariane 6 and Vega C. For example, going to the moon, which would be a first one for Europe. So that's quite exciting perspectives.
You're going to hear the DDO call out the 1 minute mark.
Attention pour moins 1 minute.
DDO has just said he's going to call out the 1 minute mark. DDO is the range operations manager for the mission.
Stop, à 0 moins 1 minute.
He has just called the 1 minute mark, so we're into the final 60 seconds. And we'll let you watch the mission. We're going to cut away, and we'll be back with you after liftoff. And once Soyuz has begun her mission. Enjoy the liftoff, everyone. We'll see you afterward.
Largage du mât KZM. À tous de DDO, attention pour le début de la séquence d'allumage du lanceur. Stop, à 0 moins 20 secondes. Largage du mât VKM. Allumage triétage. Tous de DDO, attention pour le début de décompte final. 5, 4, 3, 2, 1. Décollage.
Into the clouds and out of the clouds, and you can still see the fire, and you saw those fine shots, always impressive, no matter how many times you see Soyuz powering into the sky above French Guiana. At liftoff, 307 tons. The DDO saying all is perfect on board, all is nominal. We're going to follow her mass profile because she's going to shed a lot of weight very quickly. Rami, can you describe briefly the launcher for us?
Yes. The launcher is divided in two parts. The lower composite is a tri-stages Soyuz manufactured by ArianeSpace. The upper composite is a frigate stage manufactured by NPOL with the payload. About that, there is often a confusion because people use the same word Soyuz to talk about the complete launcher or the lower composite.
But in fact, it's actually two parts.
Yes, exactly. From the Soyuz point of view, the upper composite is assimilated to a payload as another. And the goal of Soyuz is to inject the upper part onto a suborbital orbit. After that, the frigate will manage the rest of the missions, and that's all.
We have had successful separation of the boosters, and you saw it on the animation.
Yes.
On the bottom of your screen, our altitude, you can see 53 kilometers up, and our speed, that's vitesse in French, just approaching 2 kilometers per second. The figures coming in from the downrange tracking stations into Rami's office, and we'll have more on that in a moment. Raphael, how many times have you seen a liftoff?
In real?
In real
Once.
life, yeah.
It was in
Only
Ariane
one.
5 from Kourou. And this is something that you really remember.
Yeah. You were outside.
I was outside. I was at 5 kilometers from the launcher. I think this is the closest you can get from the launcher.
4 or 5 kilometers, yeah.
Yeah.
Unless you're on board.
Sorry?
Unless you're on board.
Yeah, yeah. But yeah, I really remember the bright light coming from the sky and the sound coming from the ground. This is really impressive. But most of the time we see it on TV. Yeah.
You saw some people from the European Space Agency, Europe's space effort, a three-way affair, of course, with ArianeSpace, the French Space Agency, CNES, and the European Space Agency. Generally speaking, roughly, ArianeSpace responsible for marketing and operating the launch vehicle, ESA and its member states funding the new programs, and the CNES, the French agency, coordinating all the space base operations. Next up, fairing jettison. Before that, we are flying north to what kind of an orbit? We're going around the sun.
We're not going around the sun, but we are going around the Earth on low Earth orbit, but in a sun-synchronous orbit. So it means that when we launch the satellite there, on this orbit, the satellite will fly by an area, the one he wants to observe, at a certain time during the day. And this time is not going to change through the mission of the satellite. So it means that for example, it flies at 3 o'clock in the afternoon. Then it's always going to fly by an area at this time, and this time is not going to change.
Confirmation of the fairing jettison.
We have had fairing jettison, right? Thank you, because you have the confirmation of the DDO in your ear. The separation of fairing coming at about 150 kilometers altitude. Our speed now, as you can see, over 3 kilometers per second. Why is the fairing jettison so important? I know it's a key milestone.
Yes, good question, because as soon as the launcher leaves the atmosphere, the satellite doesn't need anymore to be protected. No. As each kilogram is important, the unuseful fairing mass is ejected. But without the fairing jettisoning, the satellite would stay a prisoner inside it. So this is why it's so important for us to have this confirmation.
We've had second stage separation. You followed it on the animation, and ignition of the third stage. You see on the screen the names of our downrange tracking stations. The Galileo station is in French Guiana. The Bermuda station, followed by Saint-Hubert, which is outside of Montreal. We'll have a word about them coming up.
Confirmation of the ignitions of the block I.
So we are right on time. The name Soyuz is, of course, familiar to you, going back to the early days of the space base, and Raphael will talk about that in just a minute. It's the workhorse of the Soviet and now, of course, the Russian and the European space program. And Soyuz in Kourou is thanks to a long association between the Russians and the Europeans, yeah?
Yeah, I think it goes back to 1966, when the General de Gaulle, that you probably heard of.
Heard the name?
Yeah. Actually, he had the chance, and he was the first political leader in the Western world to attend a launch from Baikonur, and he actually was so impressed that he pushed for a first-of-a-kind cooperation between French and USSR. And this cooperation became, with time, a unique cooperation between Europe and Russia. And in the years 2000, there was like a very emblematic mission that were launched from Baikonur by Soyuz.
You're talking about the Mars?
For example, towards Mars or towards Venus.
We'll get back to that later, yeah. But go ahead. But go ahead.
Yeah. And then this pushed some discussions about transferring the Soyuz from Baikonur to Kourou, which was very challenging and ambitious idea.
And rather visionary for the times.
Yeah, exactly, because like transferring a foreign launcher in your launch pad, this is, I think this is like really unique in the space sector. And this happened with time, and the first launch of Soyuz from Kourou happened in 2011, so almost 10 years ago.
10 years. Next year we'll be celebrating 10 years of Soyuz in French Guiana. Rami, where you usually work is an office called the CVI.
Yep.
And what's the function of the CVI? It treats all the telemetry. We saw the stations earlier. What's its role?
Oh, indeed. The CVI is a real-time monitoring. And this real-time monitoring of the launcher is probably the most important ground operation during the flight. It allows to check that the flight is nominal and to confirm to our customer that the satellite is separated as expected. Yeah. The data collected by the ground tracking station are immediately sent to the Soyuz Control Center in French Guiana and to the Frigate Fly Monitoring Center.
That's in Moscow.
Yes. About that, presently, 2 colleagues are in Kourou for the real-time monitoring, Adeline Roquet and Thomas Secretin. And 2 other colleagues are in Évry, and not in Moscow due to the pandemic, to collect the orbital diagnosis, Claude Legrand and Antoine Courtois. So hello to my colleague.
We have had acquisition of our next downrange tracking station. It's the Bermuda Islands. We're flying north along the east coast of the US. The Bermuda station was a NASA station, I think, renovated in 20 2018. The European Space Agency first began studying the possibility of launching Soyuz from French Guiana back in 1998, and they started the program in 2000. The European Space and 4. Coming up on separation and extinction of the third stage, there's the nozzle shutting down, and separation coming up. And there you are, right on time. Do we get confirmation?
Confirmation of the extension of the Bloy Ag.
Our altitude, 375 kilometers. Our speed climbing to approaching 7 kilometers. Romy, why do we use a Soyuz for this mission?
Separation of the block high.
Separation of the block. Okay, so we're doing fine. Why do we use a Soyuz on this particular mission?
Why to use a... Okay. For this kind of mission and the need of several boosters and this range of payload mass around 1.3 tons, Soyuz is perfect.
Perfect? What do you mean perfect?
Perfect because, in particular, due to the frigate capability, the frigate stage is very reliable, light and accurate. Mm-hmm. It's an heritage of the propulsive system of the Phobos space probe towards Mars. And the frigate can withstand long coasting phase.
You saw in the animation ignition
yes,
of the first
confirmation of the ignitions of the first frigate burn.
So we've had that right on time. There will be 2 burns that we will see. There will be another one that we won't see, but Remy and Raphael will tell us more about that. But for now, tell us a bit about the frigate, which was designed to be a separate individual orbiter.
Yes, yes. Frigate can perform some complex missions because, as I said, the frigate can withstand long coasting phase first and reignitions up to 7. And in a way, this stage will be perfect for this kind of particular mission, which is the SSO orbit.
SSO orbit. Now, we also, one of the ignitions of the Soyuz is going to be to deorbit.
Yeah.
The vehicle, is that right?
We save 1 boost of frigate in order to re-enter it into the atmosphere. Yeah. And this is very important because this way we don't leave an additional debris in orbit.
Space debris.
Exactly.
Big question.
We are actually required to do this by the French space law, which is like one of the best in the space sector today. Yeah. And you know that this debris is an issue, especially in low Earth orbit, because there are like lots of satellites up there. There are many more constellations. So it's important for us when we do a launch to not leave debris behind and to participate in a sustainable use of space in a way.
Our Soyuz that we're using is the most recent version of the famous Russian launcher that began the space race over 60 years ago. You remember it launched, well, maybe you don't remember if you're younger than I am, when it launched Sputnik, the first human into space, Yuri Gagarin, the first woman in space, the first spacewalk, the first dog in space. Soyuz originally a missile, you remember, the R-7, the world's first intercontinental ballistic missile created by Sergei Korolev.
La propulsion du frégate est nominale.
The DDO says all is perfect on board. We've had first and second core stage ignition, and the second stage and the third stage performed flawlessly, and we're into the first of the frigate burns. All in all this time, in over 60 years, all the Soviet and Russian manned missions have been launched on a derivative of this original missile, the R-7, which is today the Soyuz. Up next, a word from ArianeSpace's program director, Thierry Pham. We spoke to him earlier in the week, and we began by asking him to tell us all about the flight.
Good evening, Joshua. Well, tonight the flight VS-24 will have on board the Falcon Eye satellite for the benefit of the United Arab Emirates Armed Forces. We will use a Soyuz STA launcher with a Frigate M upper stage. And this will be the 8th launch of ArianeSpace of the year. I would like to thank Falcon Space, which is our customer, who has signed a contract with ArianeSpace in 2015.
You've talked about the flight. What exactly is the mission of the Soyuz launcher tonight?
Well, I will say that this is a standard optimization of the trajectory for an SSO flight with an ascent flight of the 3 stage, which has lasted around 9 minutes, and then 2 frigate bursts in order to inject the satellite in the required orbit. We will have for this mission a last boost to re-enter the upper stage in the atmosphere. And the Falcon Eye satellite will be separated from the launcher at approximately a bit less than 59 minutes of flight.
And how was the campaign? Any highlights? What do you think you're going to remember?
Well, I will say that it has been a long campaign with a long standby phase. We have faced some technical concerns on the launcher, but everything has been overcome by all the teams in due manner. And I would like just to highlight the fact that the professionalism spirit of ArianeSpace and Russian partners teams in order to overcome these difficulties was excellent. And I would like to thank all these people who have worked very hard on this program. The other point that I would like to say is that I would like to thank Airbus Defence and Space, our customer, and Thales Alenia Space, plus the United Arab Emirates teams, because they have all along the program always adopted constructive approaches in all these difficult times that we had with the COVID pandemic situation. And we are now here for this launch of the VS-24 flight, and I would like to wish a very long life to the Falcon Eye satellite.
Thierry Pham, many thanks. During the interview with Thierry, we were picked up by our next downrange tracking station outside Montreal, Saint-Hubert in Quebec. They have a mobile servicing system and an operations complex there, everything to monitor satellites, including crew training. If you just joined us, perfect liftoff, all the stages performed perfectly, flawlessly, only the frigate, we're in the middle of the first burn now. A single engine. Frigate is an autonomous, flexible upper stage, relatively recent addition to the intercontinental ballistic missile that we talked about earlier, first qualified in 2000.
Josh, excuse me, I received the confirmation concerning the acquisition of Saint-Hubert ground tracking station.
Terrific. So we're right on time and we're right on target. As long as I have you, the different frigate burns, we're in the middle of the first one. You want to tell us about the mission injection profile, I think it's called.
Yeah, indeed, the first burn will inject the frigate in an elliptical transfer orbit, and we need to wait on this elliptical transfer orbit because we are injected at the perigee, and we need to wait.
The perigee, sorry, the perigee is the highest point?
No, it's the
that's the lowest point.
Lowest point. And then the launcher keep increasing its altitude until it reaches the apogee. And at the apogee, the second burn will happen in order to circularize the orbit, because the SSO is a nearly polar circular orbit.
Nearly polar circular orbit. Anything to add about the orbit?
La propulsion est nominale.
SSO orbit? It's what, it's 800 kilometers up?
Yeah, and it's inclined, like Rémi said, at 98 degrees with respect to the equatorial plane.
Yeah.
And it is quite specific for Earth observation satellites that want to take pictures in visible light, because the illumination conditions will be the same when it flies by a certain point on the Earth.
Well, you can see the nozzle shutting down. This is the scheduled first frigate burn cutoff.
Extension confirmation.
You've got the confirmation. Okay, everything is happening letter perfect. Turning to our passenger, Falcon Eye will be separated at plus 58 minutes, 45 seconds, so we have a while to go. Passenger riding patiently for the moment. Falcon Eye is the 98th, we're approaching 100, 98th Earth observation satellite launched by ArianeSpace. And Raphael, Earth observation representing, I have here 13% of all satellites orbited by the group.
Yeah, this is quite a strong market.
It's a lot of activity.
Yeah. It's a strong market. It's very dynamic, and it serves a lot of applications. For example, monitoring the climate, studying the biodiversity. For example, following the migration of species. They also address lots of new digitalized markets, such as agriculture, building, construction, urbanism.
Search and rescue after hurricanes, for instance, after natural disasters.
Exactly.
Yeah, all that.
Yeah, a lot of other small businesses that require high-resolution images from satellites.
And it's a big market. Another 19 Earth observation satellites awaiting launch in the ArianeSpace backlog.
Even archaeology too.
We're coming up on our launch replay. Here we are, where you can live once again those exciting pictures, the smoke and the fire and the sound and the fury that you saw as the Soyuz lifted off just about 19 minutes ago. Any emotion seeing those pictures again?
I mean, this is always very impressive. I said that I've lived launch once, but most of the time we see it from Paris on TV, but we live it. It's still very emotional because we live it as a team with colleagues, and actually each time it's like we physically feel that we are part of teams, part of the same spaceship, and it's very very strong emotions because we really feel like part of a family.
You agree, Romain?
I completely share what Raphael said. Indeed, I never get used to these emotions with tension mixed to excitement. And in campaign, I have the feeling that everybody pushes the launcher, and at the lift-off time, I would like to be an additional engine in a way.
Good. All this proceeding normally on board. Back on the ground, we have 3 launch pads for Soyuz, right?
Yes,
Why do we need 3?
We need it to be available and flexible when we launch satellites. Yeah, Soyuz has 3 launch pads. The first one is obviously at CSG in Kourou in French Guiana. And we have performed 24 flights there so far, including 2 nights flights. There is this historical Baikonur launch pad also. And we have performed ArianeSpace and Starsem 28 launches also so far. And there is this new brand one in Vostochny. It was inaugurated in 2016.
That's the newest one.
Exactly. And actually, some of our colleagues are already there to prepare the next launch of Soyuz. So it's quite exciting. They are working hard right now in order to prepare this launch. So it's going to be another great show.
Our Soyuz pad is the 7th, and the Vostochny pad, as you mentioned, is newer. That's the 8th pad.
Perte nominale de la télémesure.
So Soyuz was the most recent pad.
Début de la phase balistique.
CSG pad was the most recent until last year, 2 years ago, when Vostochny.
Yeah.
There are 2 pads at Baikonur, I think, and there's some at Plesetsk also, I do believe. Yeah. We're going to go to another film in just a moment. With a passenger.
It's a proud moment for all of us at the Space Reconnaissance Center and the space sector in the United Arab Emirates as we are getting ready to launch Falcon Eye satellite after a journey of 5 years developing a capable system for the United Arab Emirates.
Falcon Eye is an autonomous and powerful Earth observation system that consists of 2 state-of-the-art Earth observation satellites, fully owned and operated by the UAE. The ground segment is capable of tasking, processing and delivering very high-resolution optical imagery in large volumes. A mobile ground segment is designed to be deployed globally in theaters of operations.
Capacity-wise, Falcon Eye satellites constellation are capable of providing hundreds of images with the high resolution spec on a daily basis.
Falcon Eye system will collect image in monochromatic and multispectral.
From capability perspective, The attitude and orbit control system provides the satellites with high agility.
The system is designed to assure global, fast turnaround between task and request, acquisition to the delivery of data autonomously.
It is really considered to be a capability owned by a few countries only worldwide.
Many experienced engineers and technicians with different background were selected from the armed forces units.
I am part of Falcon Eye engineering system since the beginning of the program.
I'm honored that my country provided me the chance to be part of this high-end technological program.
The Falcon Eye project work was mainly managed by an Emirati resident team in France. Daily meetings with the contractors were held to have an overview on the assembly, integration, and testing phases of the program.
They participate in Falcon Eye program to enhance their capabilities in the field of space.
And I'm very happy to have the chance to go back home with such massive experience that we have gained throughout the journey of the program.
I'm very excited to see this satellite finally in orbit, and very excited also to see how it will bring value for our country.
The Falcon Eye system added lots of capabilities to support the country mission by maintaining the security of the country and also the stability in the region.
The Falcon Eye system will provide high output of high-quality images to support critical missions, emergency relief, regional security, and peacekeeping operations. It will help to manage essential life resources such as water and monitor environmental changes and alterations to geographical features. The Falcon Eye will soar above the sky and observe the Earth with extraordinary vision, empowering the UAE's vision of peace and prosperity for the world.
We are in between the two frigate burns into what's called the ballistics phase. Is that right?
Yes, we are. This is the time of the ballistic phase, indeed.
What is that all about, ballistics phase? Why do they call it ballistic?
What we call ballistic phase is, this is a coasting phase, indeed. That means that there is no main engine activation, only a control of attitude of the launcher, provided by the small nozzles of the attitude control system.
Okay, so no forward push, no forward thrust, just corrections, yaw or pitch?
Yes, we just control the motion of the launcher.
Okay.
Without propulsions. And no telemetry is needed during this passive phase. And this is the case for these missions. We have a loss of telemetry.
A loss of telemetry, but
yes,
it's quite normal.
Yes, it's completely nominal. And this loss of telemetry will have a duration of 32 minutes until the acquisitions of the next ground tracking stations, New Norcia, in Australia. And why we can do like that? Because only the main event have to be under the visibility of ground tracking stations. And by main events, I mean that ignitions, extension of the burns, and of course the separation. Yes, but in order to restitute the flies, we are interested in having the parameter during the whole flight. This is why, if no ground tracking station is available, we are using the onboard mass memories.
And what happens there? You record it somewhere else, and it goes back to the ground stations as if it had been recorded by the launch vehicle. Is that right, more or less?
Yes, more or less. It's quite more complicated.
A little more complicated than that?
Yes, we can, indeed, we can both transmit the real-time parameter and record them. That we can do this both operation on board the frigate. But we cannot both transmit the real-time parameter and download the mass memory. Therefore, we have to wait, being in a passive phase, under ground tracking station visibility, to download the mass memory. And it will be the case because actually, at the present time, we record the flight from the beginning of the first frigate burn until the separations. And after the separation, we will be again in visibility of Galileo, and at this moment, it will be a ballistic phase. We have the opportunity to downloading the mass memory.
It is more complex than I made it out to be. Okay. The decision of the European Space Agency to introduce Soyuz to the Guiana Space Center was a very big step, coming after, as Raphael said, a long history of association between the Russians and the Europeans. And now it has led to constellations being a big part of their market, isn't that right?
Yeah, constellation. We have at ArianeSpace gained some valuable experience on this big market. It goes actually back to 1999 when we first deployed with Soyuz the Global Star constellation. We had like 12 launches with Soyuz back then. It was like a telecommunication constellations in low Earth orbit for this American company, Global Star. And so we also used Soyuz to deploy the O3B constellations. So this one is going in medium Earth orbit at 8,000 kilometers from Earth. Yeah,
it's another orbit.
Yeah, exactly. And we were launching with Soyuz 4 satellites at a time there. So now 20 satellites of the O3B constellations are there. And we also use our lightweight launch vehicle, Vega, to deploy this time Earth observation satellites for a constellation, planets.
If you used Vega, they had to be lighter satellites than...
They are lighter satellites, yeah. For Earth observation constellation, they are usually lighter. Yeah. And of course, we deployed this big Galileo constellation. This is a navigation constellation similar to the GPS, but European one, and it will deliver, it gives you your localization with unprecedented precision and detail. And we use for this Ariane 5 and Soyuz. So we were launching 4 satellites at a time on Ariane 5 and 2 satellites at a time on Soyuz. And we deployed 26 in total of such satellites. And they are in medium Earth orbits also at 22,000 kilometers from Earth. And of course, we are in a way to deploying the OneWeb constellation. This is a big one. It's also going in low Earth orbit.
That's another orbit again, but that's what, hundreds of satellites, I think.
It is 650 satellites in total. So, and we are going to deploy it by 2022 with Soyuz. So we already have performed 3 flights for OneWeb. And each flight is carrying 36 satellites at a time, which is quite a lot. So yes, to answer your questions, deploying constellations will keep us quite busy in the next years.
Okay, I have another question about constellations for you coming up. But first I want to turn to you, Romy. You've got some information for us on your screen, as I understand.
Yes, correct. Yes, I receive in live information concerning coming from the CVI cell.
Yeah, your office.
This is why I often look at my computers, of course, and in a way I can follow in live all the main events during this launch, and everything is perfect and nominal.
That's great.
Okay on board. Great. Good. I want to get back to you about constellations just for a last question. What are the main challenges that launch providers see in deploying these constellations, hundreds of satellites?
Well, first you need to be available to be able to launch as many times as you can, because constellation operators are usually required to deploy a part of that constellation at a certain time.
Many at a time. Many
they have like a deadline, and so we need to do the job as launch service providers. And so we have 3 launch pads with Soyuz, which is quite convenient for this. With Ariane 6, we will reduce the launch campaign from 30 days to 10 days. So
Ariane 6, just to remind people, that's the upgraded Ariane 5, which is going to be entering service shortly.
Exactly, it's the next generation of heavy launch vehicle of ArianeSpace.
Yeah.
And also, last but not least, we need to develop specific dispensers, because you need to carry as much satellites as you can in a single launch to be efficient. And doing so, and each satellite is going to be separated in a very specific location in space, in a single flight. So you need to have like specific interface with each satellite, which is quite ambitious. And so we do this. We have done this in the past. It's a valuable experience there. And
but
of course,
not without challenges.
Not without challenges. And of course, you also need, and this is important, reignition capability. And this is the case with Soyuz, and this is going to be the case with Ariane 6. And this is a key asset in order to deploy constellations, because you can reboost and address several orbits in a single flight.
Okay, sorry.
Excuse me, I just went to receive a very good news, because we analyzed the orbit just after the cutoff of the first frigate burn, and the parameter is perfect.
Okay, you mentioned cutoff. I'm going to have to cut you off. We have another look at Falcon Eye coming up, this time with the Falcon Eye Satellite Mission Director.
It's a proud moment for us in the United Arab Emirates, the space sector, the Space Reconnaissance Center. Falcon Eye program is a result of the continuous cooperation between the United Arab Emirates and Republic of France in the field of space. Falcon Eye is a dual-use system considered to be one of the best worldwide in terms of capabilities owned by few countries globally. Falcon Eye is a valuable asset to support the United Arab Emirates mission to maintain the national security, the stability in the region. And also to augment the civilian sectors.
All right, going back to the launch pads that you talked about, our 3 launch pads, what are the differences between the pads and the similarities? Are there any?
Well, the main difference is that Kourou is located at 5 degrees north the equator. So you're close to the equator, so you benefit from the slingshot effect of the rotation of the Earth. So it gives you an extra boost in order to launching satellites into space.
Right.
And the second big difference is that in Kourou you have this mobile gantry that allows you to, well, first protect the launcher from the weather, and also to do last minute, during the last days of the campaign, some activities, for example, mating the upper composite on top of the launch pad, on the launcher 3 days before launch. And I'm thinking of one last also difference, is that in French Guiana, there is a sort of like a wildlife. And one of my colleagues told me that he saw a jaguar turning around the launch pad. I guess
really?
that was quite scary at first. This is something very specific of French Guiana.
For French Guiana, the Amazon forest, yeah?
Yeah, I smiled that because I have memories to share with you that during the liftoff, in particular during a night launch, the noisy forests, because the forest is very, very noisy, get suddenly quiet, very quiet, so quiet, and it was very impressive. And after the launch, progressively, the noise come back, but it's very progressive.
Gradually.
It's very impressive, the silence in the forest, very unusual.
1,925 launches, that's the world record, that's how many Soyuz. No other launch vehicle can even compete. The nearest contenders were other Soviet missiles, they're called, I have it here, the R-12 and the R-14, and they flew something like 600 times. So you can imagine between 2,000 and 600, you can't compare two of the Soyuz, the workhorse. We're going to go back to Kourou now for a live interview with Philippe Pham, Senior Vice President, Head of Earth Observation, Navigation, and Science at Airbus. Philippe, I can see you. Can you hear us? Philippe Pham, can you
Yes,
hear
I
us?
can hear you. Good evening.
Good, welcome. Thanks for being with us. We have just a couple of questions for you. First question, can you tell us something about Airbus's role in the mission
I don't
today?
hear. Yes, I can hear you. Good evening. Yes, so we are proud to lead the industrial team and be co-prime for this very high resolution Earth observation mission for the United Arab Emirates. Airbus is the world's #1 provider of observation systems on the international market. Falcon Eye is a state-of-the-art satellite with our flight-proven Astrobus platform. But Falcon Eye is not only a satellite, it's a full space system, including the ground segment and the imagery processing capabilities. It will deliver top quality Earth observation imagery for our customer so that it will be beneficial with Earth observation imagery of top quality.
Very good. Separation, Philippe, coming up in just about 20 minutes from now. What will be your role once Falcon Eye has been released?
Well, our work does not stop when the satellite is finalized and launched into orbit. Before handing it over officially to our customer, we will check that the satellite and the ground system are fully operational. Then the system will be officially handed over to the United Arab Emirates, providing them with a fully autonomous access to very high resolution space imagery and services. This will be a capacity that only a handful of countries have in the world.
Okay, Philippe, the mission was possible thanks to a very close cooperation between the partners, the players, including Airbus. We've been hearing a lot of that. What can you tell us about this cooperation?
Indeed, this mission was the result of a close cooperation at various levels. First, governmental, between the United Arab Emirates and France. Second, industrial, with a close cooperation between Airbus Defence and Space and Thales ArianeSpace. On behalf of Airbus, I would like to thank our customer, the United Arab Emirates Armed Forces, for their trust and the very constructive steps implemented since the very beginning of this ambitious mission. I would like also to thank Yasat and their consultant, as well as ArianeSpace, CNES, the Guyana Space Center, and the Russian teams supporting the Soyuz launcher. Thanks also to the French government for their support throughout the various stages of this ambitious program. And I would like to conclude in thanking again our customer for their trust, their resilience, their patience throughout these last few months, weeks, and days until the launch tonight. Thanks again.
Okay, Philippe Pham of Airbus, many, many thanks. We're going to go to another interview now. We spoke earlier with the two satellite program managers, Michel Roux and François Villasec. We began by asking them to tell us about the Falcon Eye program.
So Falcon Eye is an Earth observation system for UAE Armed Forces. So it's a full turnkey system in which the satellite is a sensor, and we have also delivered a full ground segment which has been developed and deployed in Emirates. What we did also is a training of a full team of UAE people in order to operate this system. For the ground segment details, I will leave the floor to François.
This ground segment, commonly developed with Airbus, is capable to control the satellite, to prepare the request of images, and to produce images and intelligence report. This ground segment is located in different sites in the UAE and is capable to be interconnected, and we have as well a capacity of deploying a mobile ground segment.
Can you tell us something about the satellite itself now?
The satellite has been also jointly developed and designed by Airbus and Thales ArianeSpace.
So I will not go in detail on the performances of these satellites, which are confidential, but at least I can tell that it has been designed for 10 years operation in flight and is weighted about 1.2 tons. On Airbus side, we have designed the platform, which is an agile platform, and we were also in charge of the integration and test of the satellite in our premises in Toulouse.
In Thales and ArianeSpace, we have developed and designed the very high-resolution optical payload, which is somehow the heart of the satellite.
How was the campaign for both of you?
So the launch campaign has been very specific. So we started early this year, and the campaign has been stopped, and stopped during several months. So, as you know, 2020 is a very specific year. It's a year of the COVID, so with lockdown, with travel restriction, with difficulty to work as we were working usually, which has created significant delays. So after 8 months of storage in Kourou, the campaign has resumed end of October for 1 month, and on satellite site, it went smoothly.
On the campaign, we can say that it is the longest campaign ever experienced for this type of satellite, and our team have support and try to reduce the schedule as much as possible, even with this very difficult context that Michel just explained.
Can we look ahead to separation? What are Falcon Eye's first operations once she's been released?
The true life of the satellite will start after separation. So the separation will take place after 58 minutes and 44 seconds after liftoff. After the separation, the first acquisition of the telemetry by our team is after 3.5 orbits, which is a quite long period. So this acquisition is done through the Kiruna antennas. And thanks to automatic sequence, the satellite will be in proper configuration to start testing when we will get visibility. So the first set of tests will be done in our premises in Toulouse over about 10 days before the handover to the main site in Abu Dhabi.
After this post-launch maneuver, an intensive period of test will start. And in fact, we will verify the satellite in orbit, and mainly its geometric and radiometric performances, and verify that it is according to all our specification of the Falcon Eye system.
All right, last question. Anything else you'd like to add?
So we would like to have a few words on the people. So first, I would like to thank the industrial team, Airbus and Thales, and the armed forces, our customer. We work jointly in order that this program is a success, and it has been appreciated with a good spirit to have a good product at the end. What I would like to add is a specific thank you to my teams, so satellite team, which is the engineering team, the procurement team, and the AIT team, and also the system team and the ground segment teams, which are both in Toulouse and in Abu Dhabi. They had very strong commitment to the program, and it has been really appreciated. Last, I would like to tell a few words on our launcher authorities, so ArianeSpace and their Russian partners. So they work very hard in order to make possible this launch this night, and we thank you them for that.
Let me associate Thales as well as this thank you, and I would like to give a special thanks to our customer and to Airbus for the good team spirit and cooperation we had all along this project, and which have helped us to overpass all difficulties. And of course, to our Thales ArianeSpace people for their dedication for the project. Thank you for that.
Michel Roux and François Villesec, many thanks. I want to get back for a moment briefly on Earth observation. These satellites are also used for climate monitoring, right?
Yeah, that's true. Yeah, it's very important, and to take advantage of the fact that satellites turn around the Earth in 1.5 hours only, so they can collect their data that cannot be collected from the ground, for example, in the atmosphere, on the ocean, the forest, the fauna, the flora, etc. So quite important to have like satellites there.
Okay. We want to go back to Kourou now for another interview with Jean-Christophe Chotard, who is the head of French and export observation programs at Thales ArianeSpace. Jean-Christophe, I can see you. Thanks for being with us. After some delays, Soyuz finally lifted off with Falcon Eye, and she's now on her way. How are you feeling?
Well, we all feel relieved and also full of pride for both teams from the UAE and their industry. Having been committed to reaching these key milestones tonight, of course, the mission will process completed its mission yet. But yes, here we are. Falcon Eye is on its way, and we are all living a great moment.
I think we have a problem with Jean-Christophe's microphone out in Kourou. I can't hear him. I don't suppose you can hear him either. Maybe we'll get that fixed. But he was, I have his speech here. He was going to congratulate the customers, of course.
Yeah, I can hear you.
Ah.
Okay.
Have you changed?
Can you hear me?
Yeah, we can hear you now. Go ahead.
Yes, you want me to resume? Yeah, I can. Can you hear me?
Yeah,
okay,
go ahead.
Good, thank you. Yes, I was saying that we want to say a big thank you to our customer and partner, the UAE Armed Forces and the UAE Space Agency, for their confidence into our consortium to provide their advanced Earth observation system. The UAE are entering a new phase in their outstanding space history. And with Falcon Eye, the UAE will belong to the small circle of nations able to operate one of the most advanced observation satellites. The UAE can be proud of this.
Right. Yeah, Falcon Eye is a technological achievement, of course, but success is not only, Jean-Christophe, linked to a sophisticated technological performance. Wouldn't you agree?
Yes, this is correct. More than a classical industrial project, Falcon Eye has been a real human venture. By pushing the technological frontiers and designing an innovative and unique end-to-end system, this program has been a real adventure and was very demanding. That is why I want to congratulate all the teams at Thales ArianeSpace in Cannes and Toulouse for their expertise in providing the best technologies for very high-resolution satellites, for the image ground segment, but also for the mobile ground station as well. We also congratulate our partner, Airbus Defence and Space. And once again, this program shows that our two companies can together deliver wonderful projects in a perfect team spirit. Thales ArianeSpace would also like to thank the French authorities for their constant support during all the program, to the customer and the industrial team too. Now, the real success factor of this venture is based on a true partnership made of confidence and constructive collaboration between the UAE Armed Forces teams and their French counterparts. And by this I mean
okay, you heard earlier from we have to cut you off because we have to go to a film. Jean-Christophe, I'm terribly sorry.
Through these 6
we
years,
have a film now, another film on Falcon Eye's prime
program
and co-prime contractors. Sorry, I can't wait. We want to apologize to Jean-Christophe Chautard of Thales ArianeSpace. We had a problem with the mics, and we had to go imperativement to the film, so sorry about that. We'll make it up to you next time. Some of the recent historic missions that you mentioned, the Mars Express and the Venus missions, Soyuz.
Yeah, the Mars Express was launched in 2003 by a Soyuz frégate from Baikonur.
Depuis la station de Núñorcia en Australie.
Hearing word from the DDO.
Yes, we have important information. This is the acquisitions of the signal of the coming from the launcher from Núñorcia in Australia.
Good.
Okay. Sorry.
And yeah, sorry, it got some valuable information of the red planet. It confirmed that there is ice water in the south pole of this planet. It took like incredible pictures of canyons, mountains, and craters, and etc.
And right on time, the ignition of the second frigate burn. Our altitude, you can see, 600 kilometers. We're getting near the vicinity of where the satellite is going to be separated, of course. Our speed approaching 8 kilometers per second. Now, this is the 30-second burn, the short one.
Yes, the short one, as I mentioned it, this burn will circularize the orbit. Few energy is needed. I have the confirmation of the ignition of the frigate.
And you can see on the screen the nozzle shutting down, and that's the end of that burn. That was a short burn. En effet. So,
few energy is needed, and therefore the duration of this burn will be very, very short.
Yeah. So we have success.
But it needs to be very accurate. Well, I have the confirmation of the extension. Indeed, this burn, the duration of this burn is very short, 33 seconds only.
So we have successfully concluded all the upper stage burns. The composite has finished its powered flight phases. So what's happening now is the satellite Falcon Eye has begun its what they call orientation maneuvers. It's being spun up, I think is the term, approaching the point where it will be injected. Is that right?
Yeah, that's right. Indeed, concerning this this phase, the tonight separation is a 3-axis stabilized mode with a dedicated pointing direction.
Début des manœuvres d'orientation.
Yes, confirmation of the beginning of the orientation maneuver. Okay. So just after the end of the second burn, orientation maneuver are realized to reach the targeted attitude for the satellite separation. The orientation maneuver are provided by the attitude control systems, and there is a waiting phase in order to stabilize the motions of the launcher. As soon as the satellite is stabilized in the right directions, the separation occurs.
All right, separation occurs, but how exactly?
How? In detail, during the stabilized phase, the command separation is sent. This will activate the release of the clamp bond of the adapter, and the release of the clamp bond will free the action of the 4 pushers, because we only need 4 pushers in the frame of these separations. With the activation of the pushers, the physical separation will occur with the deconnection of the 2 umbilical connectors. And now the satellite will move away from the launcher, the satellite in a sense, and the launcher in the reversers.
Okay, so that's going to happen in 1 minute. 1 minute, a moment of high concentration, you can imagine, in Jupiter and all the the Falcon Eye facilities, as we're approaching separation just under a minute now. Anything going through your mind? This is a very concentrated moment. People are very focused.
Yeah, concentration, of course, focus. To be honest, a little bit of tension, of course.
A little bit of tension, yeah.
And I'm also thinking that this is the last step of years of work between the launcher and the satellite teams.
Yeah, correct.
And yeah.
All waiting for confirmation from the DDO that their satellite has separated from the frigate, due to come up in just about 5 seconds from now. And there is the scheduled separation on the animation, and I mean, when you get the confirmation, then we will know that the mission has been
Okay.
dismissed.
I heard the
And there you have
confirmation
it.
of the separations. To be sure. Great. Great. Very, very great.
Well, there's the good news. You hear the applause, you see the hugs and the smiles, the happy faces as Soyuz completing her mission with successful separation of Falcon Eye at about 611 kilometers altitude over the west coast of Australia. And the signal, as Remy mentioned, will be picked up by the new North Shore ground station that's north of Perth
Confirmation de la séparation
in
nominale
Australia.
de Falcon Eye
They have a station there called DS-1A. It's Deep Space Antenna, 35-meter dish, an ESA station set up in 2003. Our mass now, by the way, down from 307 tons. All that's left is 3 tons. So the new satellite beginning life thanks to Soyuz and ArianeSpace, so you must be happy?
Oh, yes. Yes, very, very happy.
Yeah?
Yeah,
You?
relieved. It's always like, I mean, can get tired of seeing the smile on the face and the relieved faces because this is right now, like the real life of the satellite begins, and hopefully it's going to deserve address and live for many years in space. So this is really a relief.
So you're right, the new satellite beginning life, thanks to Soyuz and ArianeSpace, and work is just beginning, or soon will be, at all the posts and points around the world where people are following the satellite's first maneuver. So from those very concentrated and tense moments minutes ago, as you mentioned, you see the buoyancy in Jupiter, and of course, that is echoed all around the world.
No, for myself, I'm thinking to my colleague too, because the mission is not finished yet, indeed, and we will have another ballistic phase, and after that there will be the orbitation's burn. But so I'm thinking to my colleague in Kourou and in Evry, and to all the ArianeSpace teams, very involved in this campaign, and I'd like to thanks to our Russia partner, and spasiba, pushkavomo, rashioto, zatlishnoyu, raboto.
Which means?
Which means thank you very much for this great launch to the Russian team.
Ah, very
and
good. Very nice.
So, frankly speaking, I'm deeply happy and proud to work for my company and to do such an out of ordinary job. Yes, we did it.
We did it.
When we see such a launch sequence, we realize that this is an ambitious task to lift up a satellite from the ground to the space. So this is something that is really like a daily motivation because the show is just outstanding to see this.
All right, we're going to go back to Kourou for some final words from Stefan Israel, who I believe will be with, they're getting ready for us. I think he'll be with Philippe Pham and Jean-Christophe Chotard and Mr. Al Rumaiti of Falcon Eye for some final congratulatory words after these final moments of the separation. Stefan Israel, of course, making his way out of the fishbowl where he was first shaking hands and getting congratulations. Well, there they are, the four of them. Stefan, I can see you there. You look very happy. We saw the exciting pictures of the separation of Falcon Eye just a few moments ago. Can you confirm the mission is a success for ArianeSpace?
Yes, I confirm that tonight we have had a success with our launcher Soyuz. Falcon Eye is on the targeted orbit. Mission to success.
Okay, so some thank yous perhaps are in order. Whom would you like to thank?
I would like to thank all our teams. I want to thank for sure the ArianeSpace team, but as well the Russian team who have made this success with us. I want to thank CNES team who are with us here on a daily basis in the Guyana Space Center. And for sure, I would like to pay our tribute to our partners for the mission of tonight, the satellite manufacturer Thales Alenia Space and Airbus Defence and Space, and for sure our customers, the UAE Armed Force, and I would like now to leave the floor to them.
Yes, thank you. It is a great moment. It is a time to thank all our colleagues in Airbus Defence and Space, Alenia Space, and also ArianeSpace. We are proud of this moment, and also I'd like to thank my group. Thanks to the Emirate engineer who spent 5 years working hand by hand with their partner. And really I am happy. Thank you.
Great team success indeed tonight. After so many years of teamwork together, great achievement, tribute to all the teams having contributed to this success. Long life to Falcon Eye, and long life to this very ambitious mission for the United Arab Emirates Armed Forces. Thank you.
Very proud to be part of this success. This is a great page that is turning now. Long life to this project. Thank you to our customer. Thank you to the UAE Space Agency also. Thank you to the French authorities, ArianeSpace, CNES. And last but not least, thank you to the industrial team, Airbus, and the Thales Alenia Space team. This is a great success tonight. Very proud of it.
All right, Stefan, one last question. Stefan, one last question before we go. What's next? What are the next launches?
So in fact, we are going to deliver twice by the end of the year with Soyuz. One with Soyuz from the Russian cosmodrome of Vostochny. It will be for OneWeb. And we will be back here in the Guyana Space Center at the very end of the year, between Christmas and the New Year, which is quite unusual, for our last mission of Soyuz. So 2 Soyuz to come. Thank you.
Okay, Stefan Israel, many thanks. Congratulations to all of you out there in Kourou. Well, it's been an exciting evening. We're glad that you could spend it with us. Soyuz successfully orbiting a new satellite, releasing Falcon Eye right on time for the United Arab Emirates. So congratulations to everybody involved. ArianeSpace continuing the year in fine form, serving the international community. Gentlemen, any last words?
Well, yeah, congratulations to all, to the customers, to Airbus Defence and Space, Thales Alenia Space, the UAE, to our colleagues at ArianeSpace and all the partners that have been working on this flight. To be honest, in these quite tough days that we live right now, it's really, really nice to dream of space and to see such nice images and such a nice show. It's really amazing.
Yes, space adventure is probably one of the last big human adventure. And
last frontier.
Yes, yes, and I'm very proud to do that job for that, yes, yes.
All right, good enough. On that note, we'll say goodnight. Over a final launch replay, you can see the shots again. How exciting shots that Soyuz lifting off just about an hour ago. We'll say goodnight to you on behalf of everybody here in Paris and all of us in Kourou, all the others in Kourou at the Space Base. Joshua Jample with my friends Romy Chevrier and Raphael Chevrier. And thanks for being with us. We hope you enjoyed it. We certainly did. We look forward to being with you next time. Good night, everybody.